Allow a domain. Okay, we're going to find f of g of x and to describe the domain of f of g of x. So that's right there, a little bit of above halfway above that sheet. So f of x equals 3 over x plus 1, and g of x equals 1 over x minus 2. Okay, this real quick about the domain. What do we plug into first? Which function do we plug into first? Cooper?
We would plug in the g of x.
We would plug into the g of x function first. So what I mean by that is we had to find f of g of 8. You would plug the 8 into g of x and get 1 over 6. What can't we plug into g of x? What number would make that undefined? It would be a 2. So we can. So I'm going to write this down now because that's going to play a part of our domain. Because in order to plug it into f of x, I have to get an answer for g of x. So if I tried to plug in 2, I'd get undefined, and I can't plug that into the other function. Okay? So just right now, just worry about that first one. Now let's actually figure out what f of g of x simplifies to. So when we do this, take this whole function, 1 over x minus 2, and put it in for x. So it becomes 3 over 1 divided by x minus 2 plus 1. And back from earlier in the year, you cannot leave a complex fraction. So we got to simplify this to have a single numerator and a single denominator. Okay? So I got to take this right here in the denominator, 1 over x minus 2 plus 1, and I got to simplify it. We'll get a common denominator for that part. So it'll be 1 over x minus 2 plus, that becomes x minus 2 over x minus 2 because you got that coefficient of 1, or that constant of 1. And now what I can do with that is I can write this as 3 over, all right, it'll have a denominator of x minus 2. Basically, you take 1 plus x minus 2. Okay, this is the numerators, the two numerators added together, 1 plus x minus 2. Some of you will do that mentally and skip a step, absolutely fine. Combine like terms at this point, and I get 3 over, what is that, x minus 1 over x minus 2. All right. Can I leave that? No, it's still a complex fraction. How do we fix that? Well, this is a division. Remember old division by fractions? Keep, change, flip. Keep the top one, change it to what? Multiplication, flip the bottom fraction. So nothing different. Keep the top, which is just a 3. Change it to a multiplication. Flip it. And now that becomes 3 times x minus 2 over x minus 1. It would be fine to leave it like that, or you could distribute the 3. Nothing cancels. So f of g of x is 3x minus 6 over x minus 1 for that. Cool, Rose, what was my original f of x?
3 over x plus 1.
And what was my original g of x?
1 over x minus 2.
Okay, and what did we say? We said we couldn't use x equals 2. Now get to the end of this problem. What can't we use here? Can't use 1. So x cannot equal 1 as well. All right, so those are two things. Now our domain is everything but those two numbers. Your domain is negative infinity to 1, union 1 to 2, union 2 to infinity. Okay? Now I get this a lot. What makes f of x undefined? What makes f of x undefined? What number? Denominator 0, which is what x value gives us that? Negative 1. Why can I still plug in negative 1? That's still part of my domain and get an answer. Okay? So you can think about it two ways. So you can say, all right, what's f of g of negative 1? Well, what's g of negative 1? That's not too hard to figure out. That's negative 1/3, right? And so what's f of negative 1/3? That is 3 over negative 1/3 plus 1. And now, does that have an answer? Yeah. So that means it's part of the domain. 2/3, I think we get 9/2 for that one. All right, but take a look at what happens when you plug in 1 into the original function. When I plug in 1, what's g of 1 equal? Good luck, Tony.
Thanks.
G of 1 ends up equaling what? Negative 1. And then what happens when you plug in negative 1 into the f function? It's undefined. So we can plug in negative 1, but here's what happens is 1 ends up being the one that won't work. So just your original function you plug into, I'll get that. Oh, there you go. And then the end function. So you just got to be careful there. All right, that second part. Let f of x equal 2 to the x and g of x equals square root of x plus 1. All right, calculate and describe the domain for f of g of x. Well, sometimes calculate means just writing it down. Okay, there might be no simplifying at all. So f of g of x is going to equal, take the g function, plug it in for the x, so it's 2 to the square root of x plus 1. That's it. That's all you can do. Done. Done. But you do need to describe the domain. Okay, you do need to describe the domain. Take a look at it. What do we need to worry about? Tyler, what do we need to worry about?
X plus 1.
Okay, and what about it?
So they're equal.
It has to be greater than what?
0.
0. Greater than or equal to 0. So x plus 1 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 1, which means my domain, negative 1 to infinity. Okay? All right, g of f of x. What's that going to look like? Take the f function, plug it in for x, so it's going to be the square root of 2 to the x plus 1. All right, now, the radical has to be positive. That means 2 to the x plus 1 has to be greater than or equal to 0. All right, we've never algebraically done this, nor can we. So you got to use a little common sense. You got to think through this problem. Think about any x values. What happens when you plug in positive and negative x values to 2 to the x? Well, 2 to the first is 2, 2 squared is 4, 2 cubed is 8. But what happens to the negatives? 2 zeros, 1. 2 to the negative 1 is what? 2/10? 2/10? Maybe that's lame. 1 over 2. 1 over 2. There you go. 1/2. There we go. 2 to the negative second is 1 over what? 2 squared, which is fourth. 1 over 2 squared, 1/4. 2 to the negative third is 1 over 2 cubed, which is 8. Can I ever make this a negative? No, because even if I plug in a negative, I get back a fraction, but it's still positive. So what does that tell me about my domain? No matter what number I plug in for x, I get back a positive. I add it to 1. Will that always be greater than 0? So what's my domain? All real numbers. Okay? Domain is all real numbers. Negative infinity to infinity. There's no trick. You got to be able to evaluate that and look at it. Okay? Just understand it for that. All right, I know your guided notes are done, but we got to do this one. It's actually one out of the book. Not that you need to turn there. If you got room, put it on there. If not, you're gonna have to get out a sheet of paper. It's a little lengthy, but you might have room. We got to do this and find the domain. Find g of x, f of x. And its domain. All right, Emily, is any of this making sense? So what do you think g of f of x is? I hate to put you on the spot, but I will. What do we do? What do you think?
You plug in 1 minus x over x plus 2 and every spot is an x and 3.
Yes, very good. So you take that, and it goes in for this x, and it goes in for that x. So everywhere there's an x, you plug in that entire function. So we're going to have 1 minus x over x plus 2 plus 3 over 1 minus x over x plus 2 minus 4. There's 2 different ways to do this. I'm going to show you both. I don't really care which way you do it. So I am going to copy this. And then I'll come back to it right at this point. All right. One way. This is the way I usually do it. Tend for most people to understand it. I'm not saying it's the best way. It just depends on how you look at it. I'm going to get a common denominator in the numerator and a common denominator in the denominator. It's almost 2 separate problems. Let me do this. Okay. So you're almost ignoring the denominator. So take this, get a common denominator, which is going to be what for that one? It's going to be x plus 2. Okay, so let's do that. So it's going to be 1 minus x over x plus 2. And when you do this, 3 goes in the numerator, and you got to multiply it by the x plus 2. So we get a common denominator. Does that make sense? X plus 2 over x plus 2 with the 3. All right, now the denominator is a whole nother problem, but it's the same case. So I get a common denominator here. I get 1 minus x over x plus 2 minus 4, and then I get x plus 2 over x plus 2. And so I really just kind of continue this route, and I simplify. Why is that transposed? Interesting. Okay. So I do the numerator here, and I can write it over x plus 2. And really, this becomes 1 minus x plus 3x plus 6. Okay? And then over here, I get x plus 2. And then I get 1 minus x. Now, here's where you got to be careful. It's negative 4 times x, negative 4 times 2. All right? Negative 4 times x and negative 4 times 2. Simplify each numerator. What do we get then? I get 2x plus 7, right? Over x plus 2. And then the next one is negative 5x minus 7 over x plus 2. All right, we got a fraction problem, division by fractions. So we take the keep, change, flip. You take the top, it stays the same. You change the multiplication, you flip the bottom one. So it becomes 2x plus 7 over x plus 2 times. Okay, this one here flips x plus 2 over negative 5x minus 7. All right, what happens to our x plus 2's? Cancel. Cancel. And then I get that. That's your final answer. All right, take a second. I want you to think if you can figure out what the domain is. Okay, so you need to figure out what the domain is. Now let me do something here for real quick. F of g of x. No, it's g of f of x, right? G of f of x equals 2x plus 7 over negative 5x minus 7. The original g of x was x plus 3 over x minus 4. The original f of x was 1 minus x over x plus 2. All right, Adam Lippy, do you know what we can't use? What gets thrown out?
Negative 2.
Negative 2 does, and what else?
4.
No, 4 will work.
Okay, and then negative 7/5.
Okay, is it negative or positive? Anybody else check? Negative 7/5, because you move it over, it becomes positive. Negative 7/5. Just the original function you plug into, which is f of x, and then the final. Because all right, take a look at 4. If I plug in 4 into here, I still get an answer. Okay, that's always a key thing you just got to be careful of. All right, so now put it in interval notation. So the domain is negative infinity to, which one do we come to first? Negative 2, right? Union. Negative 2 to negative 7/5. Union. Negative 7/5 to infinity. Okay? All right, so I wanted to go through one of those rougher ones with you to help you out. Now, I did say there's 2 ways to do that, right? 2 ways to do that. If you do it this way, absolutely fine. The second way, I don't know, maybe a little bit easier. And right from here, this is just the exact same problem from this point here. How else could I do that one? There's another way to do this one. Okay.
Multiply the numerator and denominator by x plus 2.
You got that denominator, both of them x plus 2. What we can do, and to me, this is a little bit harder to explain and a little bit harder for some people to understand, but it might be a little bit easier. You got to multiply the top and bottom by the same thing because of math rules, keep it consistent. Now, what happens when I multiply it times the first one? It's like you just distribute it. It will do what with that x plus 2? It will cancel it. So I'm left with 1 minus x. And now I multiply it times 3, and it just becomes plus 3 times x plus 2. And then distributed here, it cancels that x plus 2, and I get 1 minus x minus 4 times x plus 2. Okay? And so that becomes 1 minus x plus 3x plus 6 over 1 minus x minus 4x minus 8, which should give me 2x plus 7 over negative 5x minus 7. Okay. I don't care. Either way, just make sure you get the right answer. And the only thing, like sometimes this is one, I don't know. I see more mistakes this way. So if you get it right, that's absolutely fine. All right, we good? All right, I'm supposed to go into section 2.9, but I think we're kind of mentally tapped out. But you do have an assignment. I'm gonna give you some time in class. I don't want to confuse you with something new. This goes over some of the problems that are similar to what you did yesterday, but then it tacks on a couple of the harder ones you did here at the end. So do these problems here. Get started. Get started. That way, if you're having issues, you can phone a friend.